Hi, we're going to talk about compression in this video, specifically the difference between lossy and lossless compression. And I'm going to start with possibly two very obvious statements, but I've got to say these anyway. The file size of a file is the number of binary digits that are needed to store it. And we have units like bits and bytes and kilobytes and megabytes to represent that file size. The purpose of a compression algorithm is to reduce this file size, so to shrink it down. A common question is why? Why do we do this? And that is obviously a good thing. We want a smaller file size, but can you put into words why that's good? Well, there are two main reasons. If it's smaller file size, it would take up less capacity of your storage. That includes both our secondary storage, which is probably what you think about when you think about this. It means we've got more capacity free for other files. But also our primary storage. So RAM in particular, if I've got smaller files, smaller programs, it means less capacity is taken up in RAM, therefore less need for things like virtual memory because we can store more files in there. But the second main reason is linked to communication and transmission of files. We can transfer files quicker if the file size is smaller. When we have to upload a file, for example, or download a file, we've got to transfer all of those binary digits across the network. And the smaller these are in size, the faster it will go. So we upload fast, we download faster, because the file size is smaller. Now, like I said at the start, there are two categories of compression algorithms. The first one we'll look at is lossy compression. So lossy compression are the algorithms which reduce the file size by selectively deleting some of the data. Now, this is the most obvious way to reduce file size, just delete some of the data, but it is selective, right? We're not just randomly cutting out bits of file. We are choosing what is going to have the least impact on our user. One of the consequences of selectively deleting some of the data is it means the original version of your file is different from your compressed version. And it's easiest to picture this with things like images and sound and movies. These are all commonly compressed using lossy compression. Here is an image, which is 18 megabytes in terms of file size. This is actually already compressed. So this is my original in this example, but it's already compressed because the camera will take the photo in a RAW format, and then it will compress it when I put it on my computer. When it makes it a JPEG, it's applying lossy compression already. So despite being quite a big file size for an image here, this is already compressed, but I can apply even more drastic levels of lossy compression. So I'm deleting even more data, and this has made a massive difference to my file size. This one on the right is 2% of the one on the left. One on the left is 18,000 kilobytes. But you can see clearly this image, you can still see it's an elephant, but it is not quite as high quality. So we reduce file size at the expense of quality when it comes to lossy compression. You can see that we've got banding in the sky here, which is quite common because gradients are not made as smooth when you apply high levels of compression. I think the image size is a little bit smaller. We've got fewer pixels being used, and it's reduced the number of colors, I'm sure. That's possibly why the sky is not as, well, it's pretty bad really. It's not nearly as good as one on the left, possibly because I've got fewer colors, meaning it is less of a gradient. So these are ways we can be clever about reducing file size, cutting out the number of colors, removing some pixels, potentially merging some pixels if we are able to. If they're pretty similar already, this reduces the amount of binary data needed to be stored, which is why our file size reduces. When lossy compression is applied to sound, like my audio is now, this is being compressed using lossy compression, it will be, for example, measuring the wave at fewer time intervals, so reducing what's called the sample rate. It might also store each sample using fewer bits. It might also cut out certain frequencies which can't be heard easily. It might merge certain similar volumes together because they already sound pretty similar. It does things like that to cut down on the file size. The alternative approach is to use lossless compression, which, as the name would suggest, doesn't lose any data. But to put it in a more A-level way, what a lossless compression algorithm does is instead of deleting data, it just rearranges the way the file is represented to make it be more efficient. Efficient is a word in computer science which is overused quite a lot. But in this case, this is just trying to minimize file size without actually deleting anything because no information is lost in this process. Lossless does not cause anything to get deleted. So because it's not as brutal as lossy can be, it's almost always not as effective. So if we're applying lossless to an image or sound or a movie, it's not going to be as effective as lossy in most cases. However, it is required for text files. We cannot use lossy compression on anything with text in it. So Word documents, but also things like program code. Program code will have text in it, albeit converted to binary eventually. We cannot just go about deleting some of that binary or some of that text because it will change the meaning of that text or the program. So lossy can only be applied to things where the quality can change without really affecting the user so much, like images, sound, videos. We can't apply lossy to anything with text inside it, but also programs as well. So to bring back our kind of two lossy compression images, well, if I was to apply lossless compression to an image, I could do this. I might choose to apply lossless if I don't want to affect quality at all. And it will reduce file size almost always, but not by nearly as much as lossy would. However, we should not be able to spot any difference between the left image and the middle image here because middle one used lossless compression. There should be no change in quality because nothing was deleted. It's just being more clever about how it's being stored. And we'll look in the next video about how we could possibly go about applying lossless compression to things like images or sound.